The green wire, this 5 volt are connected to this pin 5. When this pin number 5 have 5 volt, it will not turn on. Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Haseeb Electronics. Friends, in this special video, why I say special? Because I receive too many comments. Sir, we are facing problem. We don't find voltage on purple wire. We have dropped voltage. We cannot, when we apply power to turn on ATX power supply, it does not turn on. I will discuss every possible fault, every possible problem in this power supply. If you are working on some power supply, if you don't have a good knowledge how to work with electrical circuits, never take a risk. Very high electrical voltage, and they are very dangerous. So if you are not aware, kindly don't do this. Basically, all SMPS power supplies, switch mode power supplies are same. Just only maybe a very small difference will be there. But if we have some concept how to deal with power supplies, any power supply, if we discuss TV power supply, if we discuss LED power supply, if we discuss washing machine power supply, if we discuss any power supply, keep the area clear, clean. No electrical debris like washers, screws, it should not here. It should be away. Second, use a series lamp. I am very sorry for being late because I have approximately more than 300 requests for videos. Sir, start TV series, sir, start LED LCD series, horizontal circuit, series parallel, because my videos are approximately 1 hour long or more than half hour. Why? When I want to discuss something, I need time. So I am sorry for late, but inshallah I hope so I will address all the questions, and it's my pleasure. But for making video, it's a very lengthy job, and I have my own office work, I have my own project. So whenever I have some free time, I make lessons. Any power supply it have. Then we have DC bus. From DC bus, it is distributed in two parts. The first part, that is standby. Its duty is to apply voltage for VCC biasing for main power supply. Main power supply or secondary power supply. We take 300 volt DC, 300 volt DC here. Okay, it will standby voltage here. This voltage will go to PC, and PC computer will give PS on command. When PS on command and VCC and these voltage are available, it will generate power output, and this power will monitor through the supervisor IC, and this supervisor IC will give feedback to main power supply. In standby section, 5 volt SB we have here, and it have its own monitoring circuit, feedback circuit to monitor it. If 5 volt are okay, At that time it will take feedback that it will keep working. If 5 volt are missing, nothing will happen. We need this voltage to power on this, and we need 5 volt SB to reset the computer, to apply power to the computer motherboard, to act on the power on command. When anyone will press the power button, we will receive voltage at this power supply section, this controller, and this will turn on the power supply, and we will receive voltage by switching off this voltage, 300 DC volt. We will take different voltage, 12 volt plus minus, 5 volt, 3.3 volt, like that, so on. As we discussed, we have EMI filter and safety circuit. What is EMI filter and safety circuit? Fuse, NTC. Sometimes we have over voltage protector here. This time I don't have over voltage protection. Okay, no problem. Sometimes we have filter here. This time we don't have, no problem, because every design have different configuration. Fuse, in this power supply, fuse is here, NTC is here. Here fuse is here, NTC is here. So sometime it is changing of the components. Sometime we are using this IC here, 82005. Here is 7520, that is also SDC2921 TL494 6105. Any one IC design, manufacturer will different, number of pins will different, but the function will remain same. I have this power supply. We have in this diagram, in this is very best power supply, we have some filter here, bridge rectifier here. After bridge we have here a 5 volt generator, that is small transformer, and then 5 volt section. We will receive 5 volt, and that time we have also a bisect power supply, 16 volt bisect power supply for the transformer, signal transformer. And in the end we have 7527 supervisor IC. It will receive voltage from the output section, and it will check them for proper availability. If any voltage is missing, it will not allow to turn on power supply. Okay, this is the first design. If we see some other diagram, here we have 6105. We have 3.3 volt sense circuit. Actually, in ATX power supplies, the biggest headache, that is for repair. It is very best supervisor. It supervises all the outputs. If any output is going wrong, up or down, it will disable the outputs. It will stop the switching. What we will do to work on any ATX power supply, just only check the part number here on this IC. 7520. Another IC, SDC2921. Here is another power supply, 6105. It is taking output from output section. Actually, this is the main issue. These ICs very rarely damaged. These are very safe and protected. But if we have some problem in output section, they will monitor the output, and at the same time they will not allow the output. It is the basic issue for repairing these power supplies. Just only go to the internet, check the data sheet, see the pin out. Where is 3.3 volt? Where is 5 volt? Where is 12 volt? These three inputs, 1, 2, 3, these three pins of any IC In this IC we have at pin number 3, 4, 5. In SDC2921 I have pin number 1, 2, 3. Actually these 3 pins are the basic problem. Then you have to check the VCC. If you have VCC, then we have to monitor these 3 pins. Our problem will be solved. And today I am discussing 7520 IC. It have 1, 2, 3. If we see here, SDC2921, 1, 2, 3, 1, 2, 3, pin number 4 PT, pin number 4 PT, 5 is ground, 6 is RT, 7 is C1, 8 is C2, it is output. 9 is remote, 10 is SS soft start capacitor, power good, detector, this is protection, VCC, OP out. Here is voltage adjustment, V adjust and negative input, inverting input, non-inverting input, non-inverting, inverting input. So in this SDC2921 we have VN negative, VN positive, it is also the same pins. So we can say 7520 and SDC2921 are similar. If we see this IC 2005, pin 1 is negative inverting input. Here is negative inverting pin number 15. So 15 and 1. OP out pin number 16. Here is OP out 14. So it is changed. We adjust pin number 2. We adjust pin number 16. So it have some change in pins. Other 1, 2, 3. The similar same. PT is here. PT is here. Ground pin number 5. Here is ground pin number 7. CT. Here is CT. Here is capacitor. Soft start capacitor here, pin number 10. Here is CT, pin number 8. C1, C2 output of pulse width modulator to drive. Remote on command, pin number 9. Remote on command, pin number 11. So it's working like this. So let's start. First problem, in any power supply, the fuse burnout. How to check? Set multimeter to continuity. Connect at input terminals. If you find short, that means we have problem in somewhere. Any component is short. Diode is short. NTC is short. Sorry, NTC no. NTC is okay. It does not short. Maybe we have voltage arrestor short. Then a very simple and basic test. Another warning, if you are not aware how to deal with these components or you don't have a good knowledge, never try this, because here are very dangerous voltage. So now we have 2 capacitors here, 1 and 2, and they are connected in series. One capacitor here. These are the test points. One capacitor here. This end is negative. This is positive end of the second capacitor, and this is negative end of the second capacitor. So positive, negative, positive, negative. So this end is negative and this end is positive. We will find DC voltage here. Set multimeter to diodes. Connect one lead capacitor negative terminal, one lead here, one lead here. It will give 0.5 volt drop of the resistor, of the diode, of these diodes. If you find continuity here, like short circuit, how? If your fuse burn out again and again, I can say this diode is short circuit. I made a jumper for this diode. This diode is short circuit. Here I find okay. Now go to the other terminal. We will find if one diode is short, we will find continuity here. If the other diode is short, we will find continuity here. Any one diode will short, it should not give continuity here. If any terminal giving continuity direct, that means the bridge rectifier is bad. At this point, we received continuity. Now swap the leads. Red lead, black lead. Now it should not give continuity because red lead was here, and I received 0.5 voltage drop across the two diodes. Now I will change red lead here, so it should open. Now move this lead. First we tested this end, now move to second capacitor. This capacitor positive terminal, this capacitor negative terminal, this capacitor positive terminal. Move here. Power must be removed. Power should not applied. If you test with applied power, you will damage the multimeter or the board, or it will make problem. So we tested the input section. Now continuity to both ends of the capacitors. If you find short circuit here, that time we must have some problem, something short circuit here. How is the circuit working? We applied voltage here, this point. It is coming directly to the diodes, this diode and this diode. The second end, from here to fuse, here is fuse. From fuse, NTC and these diodes. This end is applying positive voltage here, and this end is applying negative voltage to the capacitor. So let's apply voltage. Connect multimeter to AC, and now this is our lamp. Series lamp is very useful for testing the power supplies. We can see if the power supply is good, the lamp will start for a while, turn on, and then it will go in off state. If it is on directly, that means we have something short in the power supply. You see it will give a slight illumination, then it's off. I will demonstrate how we will find the problem. Set multimeter to AC. In the input we are finding 231 volt. So anytime you find the lamp is illuminating, that means we have something wrong. We have to check the circuit. Now in first step, set multimeter to DC. Connect one lead to capacitor negative terminal and other lead to positive terminal. We must find 300 plus volt. If any capacitor is bad, how we can determine? Check AC voltage. How much voltage are here? 231 volt. 231 volt, multiply it with 1.414 volt. It should be the capacitor voltage. AC input, this is formula, 230, multiply with this. These voltage must be at the capacitor, 330 plus volt. If you don't find these voltage, that means if you find 220 volt DC, that means we have some problem. 270 volt DC, that means we have one capacitor bad. So here I have 325 volt. That's good. That means our circuit is working. In the first step, for testing this circuit, any ATX power supply, you have to go directly to this purple wire. This purple is standby, SB standby. We have to go at SB. SB is here on this capacitor. On this capacitor, yes, this capacitor is standby. So we find 5 volt, 5.2 volt. It must be available. If we don't find, that means our power supply will not work. If this power supply is not available, that means, because this is the basic key point, this IC, and we have to check VCC at pin number 13 of this IC. I will connect one lead to ground, black lead, for easiness. Black lead here. Now we will go to pin number 13. That is 1, 2, 3, 4, 5, 6, 7, 8 from left to right side. 1, 2, 3, 8, 9, 10, 11, 12, 13. 13, 14, 15, 16. It is pin number 13. 5.2 volt. This voltage must be available at this pin. If you don't find what to do, we have to trace the standby section. Where is standby section? We have here any power supply, power transformer, signal transformer, the small one, signal transformer, the small one, and standby power. This transformer is standby power. So we have to trace this. In some power supplies there is a transistor based. Some they have IC. This SMPS, this switch mode power supply have IC. Forget about what is there. It will take direct voltage from the main capacitor. As we discussed, it will take direct voltage to standby section and it will give us 5 volts. So this IC will drive this transformer and we will receive two type of voltage. 5 volt, yes, that's another question. From standby section we take two power supplies, 5 volt and 12 volt, because in the secondary we have two power supplies, two windings, 1, 2, 3. Center tape transformer, one pin is ground, and here we have main diode, one diode and two diodes. These two power supplies, the one power supply is used to give 5 volt, the second 12 volt power supply will apply to this signal transformer, center tape winding. This center tape will take 12 volt from standby section. So in the standby section we receive two type of power supplies. The first power supply, we can see here we have two capacitors. First capacitor, second capacitor. The first capacitor is connected to this diode, that is here. From this diode output section, cathode side 5.2 volt, and there is another small diode inside. Here inside this diode, it will connect it to this capacitor. It is giving 9 volts. From 9 volt to 12 volt we will find here. this 9 volt is used to switching of this transformer, signal transformer. When the power supply will start, it will take these voltage for switching, because that time we are not finding any voltage for switching, so these voltage will be applied to the signal transformer. When the power supply will start functioning, at that time this 12 volt, because here we don't have power supply in this point, at that time these 12 volt will be switched, and there is a diode here. This diode, at that time this diode will apply power. At that time this diode will apply one-way power for this transformer. So we need two type of power supplies from standby section, and we have to check this capacitor and this capacitor. If we find 5 volt but we don't find this voltage, power supply will not start. Or maybe we find this capacitor bad, at that time power supply will turn on, turn off, turn on, turn off, because it will not hold the charge. So you have to check these voltage, 9 volt, at this capacitor 5 volt. It is our basic requirement. Check pin number 13, 5.1 volt, standby section 5.1 volts. Then we have to see the green wire. Green wire must have 5 volt, around 5 volts. If we don't find these voltage, very little components. This is section, one transistor here, one transistor, 4 diodes, 3 or 4 diodes in this section, in the driver section, inverter driver section, one transistor, and it is flyback system. 1 diode, 2 diode, 3 diodes, 3-4 resistors. These are the total components. One optocoupler here, and we have 2 resistors for biasing here for the optocoupler. Just only, it is total combination. In the output section we have this rectifier and that rectifier, one capacitor here, one capacitor here. This will drive, this will apply the biasing voltage for this chip, and from a resistor we will find these voltage at power on command. Now check pin number 9 of this IC. Here is pin number 9. Pin number 9 should have 5 volt SB. Sorry, 5 volt. The green wire, this 5 volt are connected to this pin, pin 5. When this pin number 5 have 5 volt, it will not turn on. For this IC it is pin number 9. For other ICs maybe we will need another pin for standby. Now I will make ground, so I grounded this 5 volt power on, PS on command, and we will check the voltage at this pin. It must be 0. If we don't find voltage, if we don't find ground here, we cannot turn on power supply. First step. Now we check power. We have 12 volts, we have 5 volts, ground, 3.3 volts, 3.3 volts. If we see pin number 1, 3.3 volts, it must be available. Why? Because this IC needs 3.3 volt for working, proper working. Pin number 1, 3.3 volt. Pin number 1, I need 3.3 V33. Pin number 1, V33. 3.3 volt must be present. So 3.3, 5 volt, V5, that means 5 volt must be present. Then we have 4 volt. This is 12 volt section. 4 volt from 12 volt section. If we don't find these voltage here, these 3 are the basic voltage we must find here. It should be available. If we don't find these voltage, because If we have something wrong in 12 volt section, this 4 volt will drop. At that time we will not find the proper output. This IC will allow once turn on and then it will go in off condition. Why? Because it will not find the 12 volts. If 5 volt here, this 5 volt, this 5.19 volt, the same voltage are applied here. If we don't find these voltage, we will face problem. So for working proper functioning, we have to verify this circuit. Suppose this rectifier is not working good, 12 volt section, 5 volt section is not working good, 3.3 is not working good. We will immediately, it will disable the output, it will disable the switching. So C1, pin number 7, it is in that condition when it is working good. C1, we can set frequency at hertz, 37 kilohertz, 37 kilohertz, 37 kilohertz. When the all voltage are good, these two signals are applied to these two transistors here. This transistor and this transistor. When the all inputs are good, 37, 37, so it will apply to base of this transistor and base of this transistor, 37. So these voltage will switched through these tracks to this transformer, this small signal transformer, the central one, and after that we have a pulse forming network. There is a pulse forming network in the secondary side of this signal transformer. It will make a pulses, perfect shape for switching these two transistors, and these two transistors will switch this main transformer, and we will find the voltage in secondary. If we have some issue in this section, we can bypass the safeties to test it. For example, this section is short from here or from the outside. Pin number 3, locate the pin number 3 for 12 volt, pin number 2 for the 5 volt, pin number 1 for 3.3 volt. 1, 2, 3. Pin number 2 to this resistor, 10 ohm resistor, and 10 ohm resistor is connected to this 5 volt. So 5 volt are applied to this resistor. For testing, if we have something wrong, maybe this capacitor is bad, this capacitor is bad, any capacitor is bad, remove this resistor. Remove this resistor and connect pin number 2 to standby section. Now I will connect oscilloscope, pin number 7 and 8. 7 and 8. So I connected this ground, yellow is ground, and I will connect ground line to both inputs of this oscilloscope. And when you want to connect oscilloscope, it must be isolated. Oscilloscope must be isolated from main power supply. This channel 1, channel 2. It is in good working condition. This time I am taking pin number 7 and 8 output. It is a good working condition. The both signals are switching. This time I have outputs. I have 12 volt, I have 5 volt, I have 3.3 volt. For example, now, so this time our both channels are switching. Now it is a good working condition. If I have, for example, any power supply is short, this jumper is connected, the other voltage main supply is connected, this supply go in off condition. Now I remove power and I will turn on after a while until the capacitors discharge. Now the level is going down, standby section is grounded. Now it started switching again. It is in this condition that we have voltage. Any power supply is out of limit or it is loaded, it will make problem. What to do now? We have to apply a simulated voltage on these pins. Suppose I have a permanent short circuit here. For example, this capacitor is short. Where is that? For example, this capacitor is short permanently from inside, or this diode is short. What we can do? We cannot find output. In that case, we have to make a bypass. How to bypass? I have uploaded a detailed video. I will give the link in the description and you can find that. In that condition, we have to remove 5 volt sense line. 5 volt sense line. This resistor we will remove it. Then we will remove a resistor connected to pin number 1, 3.3 volt section. So in that condition we will remove, yes, this resistor. This is 3.3 volt. We have to remove this resistor and it is connected to 3.3 volt section. Then we have to disconnect pin number 3, that is 12 volt sense line, this resistor, 1K resistor. Remove this. What we will do, (5 volt SB), you have to take 1, 2, 3 resistors. The first resistor we will make this one 3.3K. This resistor must be 700 ohm. This resistor 1K. We remove a resistor connected to pin number 2. Remove this resistor and connect this pin number 5 to VSB, 5 volt SB. This pin number 2 to this IC 7520. If you have another IC, if you have 782005, at that time you will connect pin number 4 to SB and remove the resistor and connect 5 volt to that pin. Okay, V12, it need 4 volts, so remove the resistor connected to pin number 3 in this condition. And if you are using this IC, that time pin number 5, it will here pin number 5, so it will go to pin number 3. Here we will find 4 volts, here we will find 3.3 volts. This 3.3 volt, pin number 1, remove resistor, open one end open one end. I did uploaded a detailed video, and I will give the link of this video in my description, so you can find this video. And it is very easy. Just only take 3 resistors, remove this resistor, this resistor, this resistor, and connect this. Because it is 5 volt, connect it to 5 volt SB. When we will do this job, what will happen? Because this IC will receive power when the power supply is powered on. If we have some issue in any circuit, 3.3 volt section, 5 volt section, 12 volt section, if we have any issue, any problem in any component, diode is short, capacitor is short, capacitor is not holding the charge, it is not regulated, so this IC will not allow to turn on the system. For testing which section is making problem, we have to simulate with this voltage. So this IC will consider that everything is good. So when you will make a jumper between green and black, it will turn on, because this power supply have this voltage. So in that case, your power supply will work properly. If it does not work again, when you connect this in this way, that means we have problem here. Or then we have to check the frequency at pin number 7, 8 of this IC, because it is C1 and C2, collector number 1, collector number 2. If we have any issue in regulation, this IC will not allow to turn on the system. So when we will make a bypass in this way, this IC will turn on. After that we can check the voltage here, here, here. If any voltage are out of limit, we can check that circuit immediately. It is very easy. Just only make a bypass in this way. I hope so this video is good for you. If it is good, you can like, subscribe and share if you want. Thanks for watching. Assalamu alaikum warahmatullahi wabarakatuh.